So in this introductory video, I just want to cover the concept of energy. Most of this is really introductory and meant to be useful when we're going to add more complexity in future units. But this topic is briefly brought up in Chapter 2, and so I want to discuss it in a little bit of detail. So what is energy exactly? Often in textbooks we just try and define it with very vague ideas like it's the ability to do work. I would just add to that by saying that energy itself is not matter, it's not stuff. So maybe another way of thinking about energy is it allows objects, it allows matters to undergo changes, it allows them to be active, it allows them to do things. Really we can refer to energy in terms of objects like electrons, like your textbook talks about. We can talk about chemicals and the energy they contain, and we can even talk about objects that we can see, like tennis balls, as having energy. So you're going to see the concept of energy constantly talked about in really any scientific course. And we're going to talk about just kind of broad transformations of energy that can occur in this video. And what I want you to kind of think about first is that if an object, for whatever reason, has a high energy state initially, it might be able to do work, it might be able to do something, it might be able to move to a state of lower energy. And I just want you to appreciate that, kind of like a ball rolling down a hill, that happens all by itself. We don't have to help that occur. It just sort of happens all by itself. So, for example, if I were to hold this tennis ball up and sort of put it at a state of high energy, it falls to a state of lower energy all by itself. I didn't have to push the tennis ball down to a state of lower energy. It just sort of spontaneously did it by itself. So I just want you to think of movement from high to low energy as being spontaneous, is the fancy word, or just sort of able to occur all by itself. Because when we talk about objects that are high in energy, we might talk about high energy chemicals later or high energy electrons later. When they're high in energy, I want you to think of them as like unstable. Another way of thinking about that is that they're very reactive, they're able to do work, they're able to do something. And so, again, we're going to apply this concept of high to low as sort of something that can happen all by itself in several upcoming units. So, high to low energy states, particles naturally moving from high to low concentration. We'll even talk about this kind of fancy concept of water potential when we discuss osmosis. Water will always move from areas of higher water potential values to areas of lower water potential values. But we'll discuss all of that a little bit later on. So you might ask the question then, why does any object exist in a high energy state then? If it's just could naturally go all by itself to a low energy state, why aren't all objects in low energy states? And the answer to that is that often, or at least sometimes, an object is sort of trapped in a high energy state because perhaps in order to get to a lower energy state it involves some kind of transition. In chemistry later we're going to call this a transition state when we talk about chemical reactions. But there might sort of be, while it's generally going from a higher to a lower energy state, there might sort of be this temporary state where the object is actually even higher in energy than it was initially. And so it's sort of got this hill to get up before it can then go downhill. And so it's sort of effectively trapped in a higher energy state until it can either get the energy that it needs to get over that hill, or, as we're going to discuss in cells, cells sort of have a different way of helping chemical reactions occur and get past that transition state hill. So the other thing I just want to briefly introduce is that we can actually make reactions occur where maybe initially an object starts out in a low energy state and actually finishes in a high energy state. That's like a ball rolling up a hill. It's just that that isn't going to occur all by itself. If I were to place this tennis ball right here, I've never seen it levitate up all by itself to a higher energy state. I can make that happen, but I'm going to have to add muscular energy. Notice that my big muscles are enabling me to lift this tennis ball. But if I use muscular energy, I'm able to add to the energy of the tennis ball, and now I've put it at a higher energy state. So high to low occurs all by itself, but low to high requires my intervention, requires my adding energy to the system. Low energy objects are naturally very stable and inactive, and we're going to have to add energy to the system to force them to become more unstable. So low to high reactions are not spontaneous, and we'll see that in several cases this year. Low to high energy reactions, like photosynthesis, for example, we'll talk about later. We can also force particles to move from lower concentrations to higher concentrations. Maybe you remember that. We're going to call it active transport later. So all I was trying to do in this video is sort of introduce a few concepts that will be incredibly useful later. We're going to talk about energy in much more detail upcoming soon in the future. And I just wanted to kind of introduce this lingo of high to low being spontaneous and low to high being not spontaneous.